In this lesson we will consider displacement as a function of time. Displacement might be a new word for some students. It means change of place or position. Mainly we use the word position. It is normally measured as a distance in a particular direction from a fixed point, such as the movement of a particle along a straight line from a given point, such as the origin. Now, there's a difference between displacement and a distance. The distance is always positive, has no direction. You are measuring distance from a point A to B. The displacement has it's different in a way that it has a direction. It could be negative or positive. The next thing we'll talk about is the velocity and the speed. As well as there was a difference between displacement and distance, there is a difference between velocity and speed. Speed is always positive, while velocity can be negative, and it depends on the direction of the particle. The rate at which the velocity changes is called acceleration. So, acceleration is the rate at which the velocity changes. And therefore the motion, if the motion slows down, then we will have a negative acceleration. That's, as we say in everyday terms, we say we are braking. So when you're driving and you brake, you're slowing the motion, so the acceleration is negative. And the acceleration can be found by differentiating the velocity, which is a equal dv dt. As an application to velocity and displacement and acceleration, we'll look at this example. A particle moves from a point O along the line so that its velocity is given to us by this expression. Find the initial velocity of the particle. Whenever you see the word initial, that means at t equals 0. Of course, substituting t equals 0 in this expression, you end up with v equal to 9, and the units is meters per second. So we have the initial velocity. Now, find the velocity of the particle after 2 seconds. Again, we have to find v at t equal to, substituting this in the expression above, we end up with 3 times 2 squared, t is squared, minus 12 times 2 plus 9, and this will give us at the end negative 3. Now, having that negative answer, it means that the velocity is 3 meters per second, moving in the negative direction. Okay, now find the expression for acceleration of the particle at time t. And as we previously discussed, acceleration, which is denoted by the letter A, is actually equal to dv dt. So from the expression back to the original at the beginning, v equal to 3t squared minus 12t plus 9, it will give us 6t minus 12. So therefore this is our expression for acceleration. Now the next part is asking at what time is the acceleration 0. That is when is a equal to 0. So from the previous part we found that a is equal to 60 minus 12. Put that equal to 0 and solve the equation, and it gives you 6t equal to 12. Therefore t is equal to 2. So 2 seconds. At 2 seconds the acceleration is actually equal to 0. The next part, find the times when the particle is stationary. And the word stationary, directly we can think back to velocity should be equal to 0. So the particle is stationary at that v equal to 0. back to the expression that we have before, which is 3t squared minus 12t plus 9 equal to 0. And as you see, it's a quadratic equation, and there is a 3 can be taken as a common factor, which makes it easier to factorize later on. So it's 4t plus 3 equal to 0. Now factorizing the part t squared minus 4t plus 3, it gives you t minus 1 and t minus 3, which is equal to 0. Therefore, the particle is stationary when you actually have t equal to 1 and t equal to 3. So that's when the particle is stationary at 1 second and 3 seconds. Next part is finding the expression for displacement. So we are going backward. So we've got the velocity. To find actually the displacement, we have to integrate to find it. So v is equal to x dx dt, which is given to us by 3t squared minus 12t plus 9. So we are finding the primitive functions of that. Therefore, x is actually equal to t cubed minus 12t squared over 2 plus 9t plus c, which gives us the expression at the end. Now we're after finding c. Now we're after finding c. Since the movement starts from the origin O, so therefore we have x should be equal to 0 when initially t equal 0. Therefore, if we substitute that in the expression above, we end up with c equals 0. That's when we can finalize the actual x. The displacement is equal to t cubed minus 6t squared plus 9t. Now we have an expression for displacement of a particle. The next part is sketch a graph of the displacement. So we're supposed to sketch the displacement with respect to time. So x against t. That's what we have to label the axis. Now it has to be between the time equals 0 up to 5 seconds. To actually find all this information to graph, we are given the x, the displacement, which we found in the previous part. So the next step is actually to factorize this. And if we take t common to make it easier to factorize, you end up with a quadratic equation in the bracket. And that's easier to factorize the inside, which gives you, as you notice, it's a perfect square, so it's a t minus 3 to power 2. So from that we end up with, if we substitute for x equals 0, you will end up with t equal to 0 or t equal to 3. So that means at the displacement is equal to 0 when t is equal to 0, which you can see here, and when t is equal to 3. Now, from the previous part, we noticed that the particle is stationary, or it has stationary point at dx dt when it's equal to 0, and we found that t equal to 1 and t equal to 3. At those times previously found, the velocity is equal to 0, that we have a stationary point. And this is what you noticed here. At 1, you have a stationary point, and at t equal 3, you have a stationary point. We have a maximum and a minimum. So when t is equal to 1, substituting, because the question is asking you to find the displacement at that time. If t is equal to 1, we substitute in x, and we end up with x equal to 4. And that's how we find that point, around 4. and when t is equal to 3, x is equal to 0, and this is the second point. So having these points would make it easier for us to actually sketch the curve. So at these points we have stationary points, maximum and minimum, and at t equals 0, that's where it touches the axis of the time at those times. And when t is actually equal to 5, to find the limits from the required, that's what's required of us, to find the time at time equals 0 and at time equal to 5 seconds. What is the displacement at that time? Substitute back in the expression given back here, and you end up with x equal to 20. And that's, as you notice, at t equal to 5, the curve keeps going, and this is the end of it. And that's what's required of you to sketch. So you need to find the displacement, put it equal to 0. From previous part, the stationary points, as well put these labeled on a graph, and when t equal to 5, x is equal to 20. All this information should be written and labeled on the graph. In this part, you're supposed to calculate the displacement when of the particle when time is equal to 4. So again, substituting t equal 4 in the displacement, you end up with x equal to 4 cubed minus 6 times 4, 9 times 4, and you end up with, at the end, t equal 4, the displacement equal to 4 meters. So, and it's still moving in the positive direction, and that's what we saw in the graph. And the last part is asking you to describe the motion of the particle for the first 5 seconds. So looking back at the graph, you notice that the particle moves for the first second. It moves forward. So in the first second, it moves forward in a positive direction, and then it stops and comes back. It stops. That's when you had a stationary point at t equal 1. You had a stationary point, so it stopped and went back, comes back during the next 2 seconds. So then it comes back, the next 2 seconds, and this is where you see at t equals 3, we have another stationary point when it was minimum. After that, it turns once more and proceeds in the positive direction. And that's all if you go back to our graph. So to explain this more clearly, as you see, the particle moves forward for the first second. So from there to there, it's moving forward. And at t equal 1, it stops. Then it comes back in the next 2 seconds, during the next 2 seconds, and it stops again at 3, and then it keeps going in a positive direction, and the velocity is increasing at all times.